This lesson, we're going to discuss the distance formula and midpoint formula. Okay, so here we have 2 points, P and Q, and if we are asked to find the distance from them, we need to be able to do that without using something like a ruler or such. So if I happen to just make this triangle, we are able to count vertical and horizontal distances, but we cannot count diagonal across the coordinate plane. So we don't have a way to do that. You could use Pythagorean Theorem if you knew the vertical and the horizontal heights, and you could use Pythagorean Theorem to find that hypotenuse there. But we have the distance formula to kind of bypass that, and this formula stems from the Pythagorean Theorem. So the formula we are going to use is distance equals the square root of, you take x sub 2 minus x sub 1 quantity squared plus y sub 1 minus y sub 2 quantity squared, and take the square root of that. A sum there. So really you're just subtracting the x coordinates, squaring them, plus subtracting the y coordinates, squaring them, and then you're going to take the square root. So this first example here, find the distance d between the 2 points -4, 5, and 3, 2. I'm just going to call this my x1, y1, this my x2, y2. It doesn't matter which one I'm calling my 1s or my 2s. I just have to make sure my x1 and y1 are together and my x2 and y2 are together. So if we're using the formula, distance equals the square root of 3 minus -4 quantity squared plus 2 minus 5 quantity squared. So that's the square root of 7 squared plus -3 squared. Underneath the square root, 7 squared is 49, plus -3 squared is positive 9. So that would be the square root of 58. That's not a perfect square, but it does not have any perfect squares that go into it. Square root of 58 is about 7.62. So that would be the distance in units between those 2 points. Next example here, consider the 3 points A, B, and C that are listed there. Part A says plot each point and form the triangle ABC. So if we plot -2, 1, 2, 3, that's A. There's B, and C is 3, 1. We'll connect those to make the triangle. All right, so that's all part A. Part B, find the length of each side of the triangle. So here it's important to know that length is the same thing as distance. They have the same meaning. So we're finding the length of each side of the triangle. So we need to find AB, side BC, and side AC. I'm going to start with side AC because it's the easiest, because it's a straight, or it's a horizontal line. So the length of AC, segment AC, we can just really count. So from A to C, it's 1, 2, 3, 4, 5 units long. And that's all we have to do for that one. Let's do segment AB. So segment AB, we can look at the coordinates above. Choose which ones you want to be your 1s, x1, y1s, and x2, y2s. So I just make the second set my 2s. It's kind of how my brain works. So if we take the square root of 2 minus -2 quantity squared plus 3 minus 1 quantity squared, that's going to be the square root of 4 squared plus 2 squared. That's the square root of 16 plus 4, which is the square root of 20. 20 does have some perfect squares that go into it. If you remember simplifying radicals here, we're looking for 2 numbers that go into 20, and we want the largest perfect square that goes into 20. So the largest perfect square would be 4. So this breaks down into the square root of 4 and the square root of 5, because those multiplied together is 20. Square root of 4 is 2. Can't simplify square root of 5. Or you can find the decimal form of that, which is 4.47. And then last, we need to find segment AC. Just kidding. Segment BC. So we'll do 3 minus 2 quantity squared plus 1 minus 3 quantity squared. That's 1 squared plus negative 2 squared, which is 1 plus 4. That's the square root of 5, which does not simplify, but as a decimal is 2.24. Okay, I'm gonna make this stuff smaller so I can move it. Okay, part C here, show that the triangle is a right triangle. All right, so we're just going to use the Pythagorean theorem here. It's going to be a right triangle if a squared plus b squared equals c squared. Excuse me. So that's the Pythagorean theorem. Remember, the c squared is always the hypotenuse. So this is going to be short leg squared plus short leg squared equals long leg slash the hypotenuse squared. But we don't know if it's the hypotenuse or not because we don't know if it is a right triangle here. So the longest side then out of all of those would be side AC, correct? Because it was 5 units. Yep. So we're going to take, this is why I use the radicals with the perfect squares and not the decimal form. We want to know, is AB squared plus BC squared equal to AC squared? All right, so I just matched that up with our triangle. So is 2 square root of 5 squared plus square root of 5 squared, is that equal to 5 squared? Well, let's see, 2 square root of 5 squared, so 2 squared is 4, the square root of 5 squared is just itself, so this becomes 4 times 5, plus the square root of 5 times itself is just 5. Does that equal 25? That's 20 plus 5. Does that equal 25? Yes, it does. So this is a right triangle. Okay. And then last here, part D, find the area of the triangle. Area for a triangle is 1/2 times the base times the height. So we now know that AC is the hypotenuse, so the base and the height we're talking about are AB and BC. Okay, so it's where the right angles meet. So our area equals 1/2. The base is 2 square root of 5. Our height then is the square root of 5. Multiply 1/2 times 2 radical 5. That just leaves us with square root of 5 times the square root of 5, which is just 5. And then area is square units. I'll just put units squared. Okay. That is the distance formula and applying it. So now let's look at the midpoint formula. All right, so here we're asked to derive the midpoint formula given that the midpoint xy is the same distance from P1 and P2. So we are told that this distance is the same. And we are also told that the two triangles that are shown there are congruent by angle side angle. So if they're congruent, then that means that this distance would be equal to that distance, and also this vertical distance would be equal to this vertical distance. So since that is true, we'll set up an equation here that x minus x1 is equal to x2 minus x. And we're trying to solve here, get our like terms together. So we're going to add x to both sides. So we have 2x minus x sub 1 is equal to x sub 2. If we add x sub 1 to both sides to solve for x, we have 2x equals x sub 1 plus x sub 2. To get x by itself, we divide everything by 2. So x equals x sub 1 plus x sub 2 divided by 2. That is this right here, the x-coordinate of the midpoint. So we need to do the same thing for the y-coordinate. So y minus y sub 1 equals y sub 2 minus y. It's the same exact process here, so kind of go fast. We got 2y equals, I'm going to go ahead and move the y sub 1 over, divide by 2. So y equals y sub 1 plus y sub 2 divided by 2. Y is referring to the y-coordinate of the midpoint. So that right there is your midpoint formula. You're really just averaging the x values and averaging the y values to get your coordinate of your midpoint. So examples here, find the midpoint of the line segment from P1 to P2, plot the points in their their midpoint. So negative 5, 5 here. That's P1, 3, 1 is P2. And we need to find the midpoint of that segment. So I'm just going to, the x-coordinate will be the average of the x's. So negative 5 plus 3 divided by 2. That's negative 2 divided by 2, which is negative 1. And then I'm going to average the y's. So 5 plus 1 divided by 2 equals 6 divided by 2. So the y-coordinate is 3. So our midpoint is the ordered pair negative 1, 3. And if we graph that, it makes sense if I drew a straight line. All right. And last one here, find the midpoint of the line segment from P1 to P2. We just don't have to graph anything here. So our x-coordinate is going to be 3 plus 5 divided by 2, which is 8 divided by 2. So our x-coordinate is 4. Our y-coordinate is going to be negative 4 plus 4 divided by 2. That's 0 divided by 2, which is 0. So the midpoint here would be the ordered pair for 0. And that is it for distance and midpoint.